So we're now going to give an example where we use the definition of the derivative to compute the derivative. And the example we're going to look at is the following. And now the question is, for what values of c is f differentiable at x equals to 0? So the point here is if we make a drawing of f, how does he look? Well, for negative x, he will be a straight line with slope c. So if c is large and positive, it will look like this. If c is small and positive, it will look like this. And if c is negative, it will look like this, something, right? So let's just do like this first. And then here for positive x, well, we start at 0. So we seem to be continuous at least. So these two guys both hit the same point at the origin. And then this guy, well, he's like x to the squared plus x. So it's like x to the squared moving a little bit faster like this. And the point is, to have a derivative at the origin, the graph needs to be smooth. It can't have any pointy bits. We're basically now asked to figure out the value of c so that there's a smooth transition between this part of the graph and that part of the graph. Because what's the problem here? So if we have a pointy bit, so let me exaggerate a little bit. So if the graph looks like this, then this seems to be a tangent line, this seems to be a tangent line, this seems to be a tangent line. And that's a sign that we're not differentiable. So if several straight lines are all tangent to the graph at this point, meaning that they only touch it in one point locally, you could say, we don't really care what it does far away from the point, but if several straight lines are able to nudge the graph at just one point here, that's a surefire sign that you're not differentiable. How to prove something is not differentiable? Just prove that the limit for the derivative, like this, does not exist. That's what it means to be non-differentiable. So let's now take a look at what happens here. Our graph looks like this. So we need to check this limit here. So f derivative at 0. So then that's lim h tends to 0 of. So now I'm exactly writing this quotient here for x equals to 0, which would be f of 0 plus h minus f of 0 divided by h. And keep in mind, when I'm taking the limit here, h is never allowed to be 0. So I'm not dividing by 0 here, but I'm dividing by something getting closer to 0. Here I'm just putting in 0. So if we look at the definition here, that means I'm supposed to use this formula and put 0. So that's just giving me 0 to the square plus 0. So this is always a 0. Now this guy, well, what is he? Well, he's just f of h, right? And now, what should I replace him by? Well, if I look at my formula here, it depends on whether h is positive or negative. So what I need to do here is I need to split into two cases. And one way of expressing this is to say, well, this is equal to these two things. So if h tends to 0 plus, I get something. And if h tends to 0 from the minus side, I get something. And here, when I tend from the plus side, I get h squared plus h, because I'm doing f of h now. So I'm using this formula with h's in place of the x's. I have minus 0. I can write that out if I want like this. And I'm dividing by h. Down here, I have to use this part of the formula. So f of h is now c of h. I still subtract 0, and I divide by h like this. Continuing like this, what am I getting? So I'm getting here, h goes to 0 from the positive side, and I don't care about the 0. Now I can cancel h a bunch of places here, so I get h plus 1. And down here, again, I don't care about the 0, so now I can cancel these h's. So I'm getting just c here. And of course here, when I compute the limit, I'm getting a 1. And here, when I compute the limit, I'm getting a c. Now, the derivative of f at 0 can only be equal to one value. So if this computation here gives me a different value here and here, this computation tells me that this thing does not exist, that this limit diverges, since it's not the same from the left and from the right. But the question now was, for which values of c does this guy have a derivative at x equals 0? But that would be the value of c for which these two values are equal. This means that f derivative at 0 exists if, and only if, which we can write like this, c is equal to 1. In this case, f derivative at 0 is equal to 1. And we are done. So this basically means, in terms of the drawing here, so I mean this drawing is rather sloppy, but apparently if I do the slope 1 here, then the transition between these two graphs have no pointy little thing here that you can hurt yourself on.